Your dog growled at the visitor before they stepped through the door. The visitor smiled. The visitor spoke warmly. The visitor did everything right. The dog growled anyway. You pulled the dog back and apologized. Months later, you found out the instinct was right. The visitor was wrong. You have told this story as evidence that animals have a sixth sense, an intuition that operates beyond the five senses humans use. The animal had no sixth sense. Science can explain every reaction you attributed to intuition. The dog that growled at the plumber who later stole from the house was reading apocrine chemistry from a body producing stress hormones associated with deceptive intent. The cat that left the room when one guest arrived was detecting a volatile signature that differed from every other guest the cat had encountered. The horse that refused one rider was sensing a cortisol-laden breath and a micro-tremor-laden hand that transmitted stress through the reins. Each reaction traces to a physical channel the animal detected and the human missed. The physics replaces the mystery. The detection is not supernatural. The detection is a sensitivity advantage operating on physical signals. The human sensory system was never calibrated to read at the concentrations the animal receives them. The animal had a first sense operating at a sensitivity level the human nose, eyes, and ears cannot approach. Dog was reading chemistry the visitor's body produced involuntarily and could not suppress. Chemistry that changed before the face did. Signals the visitor was unaware of producing. Channels the visitor did not know were open. The visitor controlled their face, their voice, and their posture. The visitor could not control a single one of the channels the dog was reading. The body was broadcasting on 6 channels simultaneously, each one carrying information the visitor did not know was being transmitted, at concentrations the visitor could not suppress, through a detection system 30 to 50 times more sensitive than anything the human in the room possessed. The body is an involuntary radio station, transmitting on channels you do not know are broadcasting, at frequencies you cannot detect, carrying information you cannot suppress. The radio station has no off switch. The transmission runs as long as the body is alive, emitting chemistry with every breath, radiating heat with every heartbeat, secreting lipids with every sympathetic activation. The only way to stop the broadcast is to stop the biology. The visitor could not stop it. You cannot stop it. No human can. The animal is the receiver tuned to every channel the body transmits on. The human in the room is tuned to 2, face and voice. The animal is tuned to 6. What the animal detected was an involuntary broadcast from a body that could not stop transmitting. The broadcast runs continuously. You are transmitting right now as you read this, exhaling 500 volatile compounds, radiating 100 watts of infrared, secreting apocrine lipids. The bacteria on your skin are amplifying into detectable volatiles. Every person near you with a dog or cat near them is being read by a detection system that processes your broadcast automatically, effortlessly, and with a sensitivity your own sensory system cannot approach. What changes in the sweat before the face changes? Apocrine sweat glands. Concentrated in the axillae, the groin, and the scalp, these glands secrete a lipid-rich, protein-containing fluid into the hair follicle that differs fundamentally from the watery eccrine sweat the body uses for temperature regulation. Eccrine sweat is mostly water and salt. The sweat you feel on your forehead during exercise, thin and watery. Apocrine sweat carries fats, proteins, and steroid metabolites whose composition changes with the emotional state of the body producing them. The glands activate during puberty, which is why children have minimal body odor. The adult apocrine system is a mature chemical broadcasting system transmitting emotional chemistry since adolescence. The secretion rate increases under sympathetic activation within seconds, faster than the conscious mind can compose a facial expression, faster than the voice can adjust its tone, faster than the posture can shift to project confidence. The chemistry is the fastest external signal the body produces because the neural pathway driving the apocrine glands is the rapid pathway that drives the adrenal medulla to release adrenaline. The sweat and the adrenaline arrive on the same neural signal. The face arrives on a separate, slower, voluntary signal. Change is adrenergically mediated. The sympathetic activation the panic discussion described, adrenaline flooding the system, cortisol rising, vasoconstriction redirecting blood from the skin to the muscles produces the external emissions the animal detects. The panic discussion taught what happens inside. This channel teaches what leaks out. the same sympathetic surge that accelerates the heart rate and constricts the peripheral blood vessels simultaneously drives the apocrine glands to secrete a lipid profile measurably different from the baseline calm profile. Fear, elevated adrenaline drives apocrine secretion with a different lipid composition than baseline. Subjects exposed to fear-collected sweat showed measurable fear responses themselves, widened eyes and increased startle reflex, compared to those exposed to neutral or happy sweat. De Groot and colleagues documented this chemosensory fear communication in psychological science. The fear chemistry transferred between humans through sweat alone, without any visual or auditory signal. The sweat carried a message the recipient processed without conscious awareness. The implication is specific. Fear has a chemical signature that human bodies both produce and receive, a molecular communication system operating below the threshold of conscious perception. If human noses with 6 million receptors can process the signal unconsciously, a canine nose with 200 to 300 million receptors processes it with overwhelming clarity. Stress, cortisol metabolites, cortisone and tetrahydrocortisol, excreted through the skin. The cortisol, the belly fat discussion described being produced by 11-beta-HSD1 and circulating systemically arrives at the skin surface as a detectable volatile within minutes of the cortisol spike. The same molecule driving the visceral fat loop appears on the skin as a chemical broadcast the dog reads from across the room. Aggression, testosterone metabolites, androstenedione and androstenone, increase in apocrine secretion during aggressive or dominant states. The chemical profile of hostile intent differs measurably from friendly intent before any expression or behavior conveys it. The chemistry changes in seconds. The face may take minutes to betray what the sweat already announced. The time gap between the chemical change and the behavioral change is the window the dog operates in. The dog reads the chemistry during the seconds before the face catches up. The growl was early because the detection system reads a faster channel than the one humans prioritize. The gap between when the chemistry changes and when the behavior changes can range from seconds to minutes, depending on how effectively the visitor controls their voluntary expression. During that gap, the dog has already classified the visitor by chemistry, while the human is still evaluating the smile. Sweat changed before the face did. The visitor who smiled while hostile produced a face that said friendly and chemistry that said threat. The discrepancy between the two channels is the signal the dog responds to most strongly. A visitor who is genuinely friendly produces matching channels, calm face, calm chemistry. A visitor who is genuinely hostile produces matching channels, hostile face, hostile chemistry. The mismatch, friendly face with hostile chemistry, is the specific configuration that produces the strongest canine response because the mismatch itself is a detectable signal pattern. The dog received both signals simultaneously. The dog trusted the chemistry because the chemistry is autonomically mediated, produced by glands the visitor cannot consciously suppress, broadcasting a signal the visitor does not know exists. The autonomic mediation is the key. The sympathetic nervous system drives the apocrine glands through one neural pathway that accelerates the heartbeat, dilates the pupils, and redirects blood flow. These responses cannot be voluntarily suppressed because they operate below the level of conscious control. The visitor who attempts to appear calm while feeling hostile can control the face, the voice, and the posture, because those are voluntary motor outputs. The visitor cannot control the sweat because the sweat is an autonomic output the conscious brain has no access to. Chemistry broadcasts from the skin. The question is whether any detection system is sensitive enough to read it from across a room. How does the dog read a chemical signal from 3 meters away? 200 to 300 million olfactory receptor neurons, depending on breed. 6 million in the human nose. The scale difference category of detection entirely. Sensitivity for certain compounds reaches parts per trillion, equivalent to detecting 1 drop of a substance dissolved in 20 Olympic swimming pools. The apocrine volatiles the visitor produced are present at parts per billion on the skin surface and parts per trillion in the air, 3 meters away. The dog detects them at both concentrations because the detection threshold is calibrated for a world where chemical information determines survival. The evolutionary pressure that produced this sensitivity operated for millions of years. Canine ancestors who detected predator chemistry from greater distances survived. Ancestors who detected prey chemistry more accurately ate. The detection system was forged by selection pressure as intense as any established receptor biophysics describes for TRPV1 pain receptors, except the canine pressure selected for sensitivity to environmental chemistry rather than capsaicin. The olfactory bulb, the brain region processing smell, occupies approximately 2% of the dog's brain mass compared to 0.03% in humans. The processing power dedicated to chemical detection is proportionally massive. Each olfactory receptor neuron expresses one receptor protein type, approximately 800 types in dogs compared to approximately 400 in humans. Each volatile compound from the visitor's apocrine secretion fits a specific receptor's binding pocket through G-protein coupled receptor signal transduction the body uses for every chemical detection system. The 800 receptor types with 200 to 300 million neurons create combinatorial detection. Each volatile mixture produces a unique activation pattern across the olfactory epithelium. The dog reads the pattern the way a fingerprint reader reads a print, not by matching a single feature, but by comparing the pattern across hundreds of receptor types simultaneously. Canine olfactory receptor diversity and its combinatorial detection architecture is established neurobiology. Walker and colleagues identified the receptor gene family in genome research, confirming the approximately 800 type repertoire that enables the combinatorial sensitivity. Stereo-olfaction. Each nostril samples independently. The brain computes the concentration gradient between nostrils to determine the source direction in three-dimensional space. The visitor's chemical emission was located and tracked by gradient before visual identification. The dog knew where the chemistry was coming from before looking at the source. Each nostril samples independently, and the brain updates the direction estimate with every sniff, identifying the strongest chemical source in a room of 5 people by gradient, the way a radar identifies the strongest signal among multiple returns. Now, temporal resolution, 5 to 12 sniffs per second during active investigation. Each sniff is a new sample. The dog builds a temporal profile, detecting changes in volatile composition across seconds. The visitor whose cortisol spiked when the dog approached produced a change the dog detected in real time. The static profile said, "This person is stressed." The dynamic profile said, "This person became more stressed when I approached." The dynamic signal amplifies the dog's alertness because the change itself is information. The visitor's chemistry responded to the dog's attention, confirming that the chemistry and the behavior were linked. Well, the olfactory arithmetic reframed the growl I had been interpreting as instinct. The dog processed the visitor's apocrine emission through 200 to 300 million receptors across 800 receptor types, computed the pattern against stored profiles of every human the dog had encountered, detected a fear-stress-aggression chemical signature that differed from every baseline visitor's profile, tracked the concentration gradient between nostrils to confirm the source, and detected the dynamic change as the visitor's cortisol spiked in response to the dog's attention. The growl was pattern recognition operating on a dataset no human sensory system can access. Nose reads the skin chemistry. Dog is also sampling the visitor's breath, and what the breath contains reveals the visitor's metabolic state with a precision that exceeds medical diagnostics. What does the breath reveal that the nose also reads? Every exhale, more than 500 volatile organic compounds, a metabolic readout the lungs broadcast with every breath, updated 12 to 16 times per minute, each exhalation carrying the current chemical state of the body to anyone with a nose sensitive enough to read it at the concentrations the lungs deliver. The exhalation plume extends approximately 1 meter in still air, and the dog sampling the air at contact distance receives the breath compounds at their highest concentration. The visitor who leaned down to pet the dog delivered their exhaled chemistry directly into the detection system at maximum concentration. Acetone from fatty acid beta oxidation, isoprene from the cholesterol synthesis pathway, alkanes from oxidative stress, dimethyl sulfide from methionine metabolism, ammonia from protein catabolism. The breath is a chemical window into the metabolic state of the entire body, updated with every exhalation, broadcasting compounds that change with emotional state, disease state, and hormonal state simultaneously. Trained dogs identify lung cancer from breath samples at 97% sensitivity. McCulloch and colleagues established this in integrative cancer therapies, Dogs detect hypoglycemia in diabetic patients before the glucometer registers, breath chemistry changing 15 to 20 minutes before blood glucose reaches the clinical threshold. The dog alerts the patient to eat before the patient feels any symptom. The chemistry preceded the perception by a quarter of an hour. The detection system that evolved to read environmental chemistry reads the body chemistry of the individual standing next to the dog with equivalent sensitivity it would use to track prey across a forest floor. Dogs detect oncoming seizures 15 to 45 minutes before onset through breath and skin volatile changes, including elevated isoprene and specific aldehyde compounds, that shift measurably in the minutes preceding the neurological event. The dog detects metabolic shifts before the body's own nervous system reports them. The breath chemistry changes with the metabolic shift. The dog reads the chemistry. The individual feels the symptom later. The animal reads the body's internal state from exhaled chemistry faster than the body's own interoception. Cortisol detection from breath is measurably precise. Wilson and colleagues measured this at Queen's University, Belfast. Trained dogs detected cortisol changes in human breath and sweat at 93.75% accuracy from a single sample. One breath, one sample. The stress hormone detected with the accuracy of a laboratory assay. One breath, sampled from the air the visitor exhaled, processed through a nose with 300 million receptors, compared against a stored chemical profile of relaxed versus stressed humans, the dog has accumulated and refined across every human encounter in its life. The dog is running the assay continuously on every person in the room. Untrained household dogs perform informal emotional state assessment as a default function of their olfactory system, encountering human chemistry. Trained medical detection dogs achieve formal diagnostic accuracy. The baseline capability is innate. Every dog you have ever owned has been performing this assessment on every person who entered your home, every delivery driver, every guest, every family member returning in a different emotional state than when they left. The growl at the visitor was not anomalous. The growl was the one time the assessment produced a result strong enough to override the social deference the dog normally maintains. The nose reads the skin. The nose reads the breath. Two chemical channels broadcasting the visitor's internal state. The visitor's body is also emitting signals that carry no chemistry at all. Thermal radiation from the skin surface and acoustic patterns from the muscles and heart, both of which change with emotional state, and both of which the dog may detect through entirely different sensory systems. What does the body broadcast in heat and sound? Stefan Boltzmann law. Every object above absolute zero radiates infrared energy proportional to the fourth power of its absolute temperature. The body at 37 degrees Celsius emits approximately 100 watts of infrared radiation at a peak wavelength of approximately 10 micrometers. You are a 100-watt heat beacon, radiating more thermal energy than a standard incandescent light bulb, broadcasting continuously in a wavelength band the dog's rhinarium may detect. Thermal pattern changes with emotional state. Facial flushing during anger is surface temperature from increased blood flow. Facial cooling during fear occurs from vasoconstriction, redirecting blood to the muscles, the same vasoconstriction the body uses to redirect blood from the periphery to the core musculature under threat. The visitor who felt a chill of nervousness upon entering the room experienced the subjective sensation of the vasoconstriction the dog may have detected as a thermal shift on the face. The chill and the thermal shift are the same physics experienced from opposite ends. The visitor felt it as temperature. The dog may have detected it as infrared. The angry visitor presents a different thermal map than the fearful visitor. Ballant and colleagues confirm that dogs' rhinaria detect weak thermal radiation in scientific reports. Whether dogs use thermal patterning to read emotional state in practice is inferred from the physics, and the inference is strong. The detection capability exists, and sympathetic vasoconstriction produces measurable facial cooling. The specific emotional state application has not been directly tested. The physics supports the inference. A thermal camera can distinguish emotional states from facial thermal patterns, and if a camera with a sensor can detect it, a biological sensor evolved for thermal detection may detect it through an identical physical signal. And then, the acoustic channel. Canine auditory range extends to approximately 65,000 Hz compared to the human ceiling of 20,000. At close range, the dog detects the heartbeat through the chest wall. Heart rate variability changes with emotional state, coherent during calm, irregular, and elevated during stress. breathing pattern, rate, depth, regularity, all shifting under sympathetic activation. Physiological microtremor, skeletal muscle produces continuous low-amplitude tremor at 8 to 12 Hz from motor unit cycling, and sympathetic activation increases the tremor amplitude. The tremor detection through direct contact is inferred from mechanosensory capability rather than directly tested, but the physics is consistent with contact range detection when the visitor's hand touches the dog. Body broadcasts on every physical channel the environment can carry: chemical through the sweat and the breath, thermal through infrared emission, acoustic through the heartbeat and the muscle tremor. The visitor controlled none of these channels. Each one operated autonomically, driven by identical sympathetic nervous system activation that produced the emotional state the visitor was trying to conceal. The concealment controlled 2 channels. The sympathetic system controlled 6. The ratio is the physics of why deception fails in the presence of a detector calibrated to the involuntary channels. Each one transmitted autonomically, continuously, without the visitor's knowledge or consent. How do skin bacteria amplify the emotional broadcast? One more amplification system operates between the chemistry and the detection. The bacteria on the visitor's skin process the raw emotional chemistry into a louder, more detectable signal. Skin bacteria metabolize the apocrine secretions through species-specific enzymatic pathways. Corynebacterium converts the apocrine lipids into volatile fatty acids through beta oxidation. Staphylococcus cleaves the protein-bound precursors and produces thioalcohols, the sulfur-containing compounds with the lowest olfactory detection thresholds of any biological volatile. Propionibacterium generates branched-chain aldehydes through amino acid fermentation. Each bacterial species processes a different fraction of the apocrine secretion through a different enzymatic pathway, and the combined output is a secondary volatile cloud far more detectable than the primary secretion the glands produced. The bacterial processing amplifies and modifies the primary chemical signal. The emotional chemistry from the apocrine glands is the input. The bacterial metabolism is the amplifier. Body odor is bacterial amplification of emotional chemistry, a 2-stage broadcast where the body produces the signal and the microbiome boosts it. The amplification is measurable. Bacterial metabolism converts odorless apocrine precursors into volatile compounds with much lower olfactory detection thresholds. The compounds the bacteria produce are smellable at concentrations orders of magnitude lower than the precursors the apocrine glands secrete. The bacteria are biological amplifiers that convert a quiet chemical signal into a loud one. The thioalcohols the bacteria produce have olfactory detection thresholds in the parts per trillion range, meaning the bacterial output is detectable at concentrations 1,000 times lower than the apocrine precursors the glands originally secreted. The microbiome is a signal booster the body carries on its own skin, and the amplification runs continuously on the skin surface without any input from the body producing the precursors. The bacteria do not respond to emotional state. They respond to substrate availability. When the apocrine glands increase secretion under sympathetic activation, more substrate becomes available, and the bacteria produce more volatile product. The amplification is proportional to the emotional intensity. Higher stress produces more apocrine secretion, produces more bacterial substrate, produces more volatile output. The system scales with the signal. The louder the emotional state, the louder the bacterial amplification, the clearer the signal the dog receives. Microbiome composition differs between individuals, contributing to the unique scent fingerprint each person carries. The dog who growled at one visitor detected that individual's unique microbiome amplified signature in a state that differed from every other visitor's baseline. The individuality of the scent fingerprint means the dog is comparing each visitor's current chemistry against that visitor's remembered baseline, detecting not just emotional state, but emotional change. My understanding of the growl shifted the evening the 6 channels converged into one picture. The visitor controlled 2 channels, face and voice. The visitor could not control the 6 channels the dog was reading. Apocrine sweat chemistry broadcasting a fear-stress lipid profile. Breath volatiles carrying cortisol metabolites detectable at 93.75% accuracy. Infrared emission shifted by sympathetic vasoconstriction. Cardiac rhythm transmitting through the chest wall. Muscle microtremor amplified by stress. And bacterial processing converting the emotional chemistry into a secondary volatile cloud. The nose reads as a complete signature. 2 channels said friendly. 6 channels said threat. The dog resolved the discrepancy by trusting the channels the visitor could not fake. Every animal reaction you have witnessed, every growl at a stranger, every refusal to approach, every departure from the room when one specific person entered, was a detection event, a biological receiver reading an involuntary broadcast from a body that could not stop transmitting on channels the conscious mind does not even know are open. Whether your pet's reaction to a specific person should inform your assessment of that person is a judgment the physics does not make. The physics teaches what the animal detects: involuntary chemical, thermal, and acoustic emissions from a body in a specific physiological state. The dog reads state, not character. The distinction matters. Someone who is anxious but kind produces the same chemical signature as a person who is anxious and dangerous. The dog detects the anxiety, not the intent. What makes the detection useful for identifying deception specifically is the discrepancy between channels. A genuinely friendly individual produces chemistry that matches their behavior. A deceptive individual produces chemistry that contradicts their behavior. The contradiction is the signal. The dog detects the mismatch between what the face says and what the sweat says because the dog receives both channels simultaneously and the channels disagree. Deception is a physiological event. The effort of maintaining a false expression while the sympathetic system is activated produces its own chemical signature, a signature of cognitive effort layered on top of the emotional chemistry the deception attempts to conceal. But the state that produces deceptive behavior, the controlled face contradicting the uncontrolled chemistry, is the discrepancy the dog evolved to detect. The deception is the mismatch between voluntary and involuntary channels. The animal detects the mismatch. The detection is physical. The channels are physical. The broadcast is physical. The receiver is biological. The physics accounts for every component of the interaction without requiring any mechanism outside established sensory science. Nothing in the physics requires intuition, a sixth sense, or any mechanism outside the known sensory capabilities of the species detecting the signal. The dog is doing what evolution built it to do, reading chemistry, heat, and sound from the environment with a sensitivity no human can match. The dog growled before the visitor crossed the threshold. The body had been broadcasting on every involuntary channel since the visitor walked up the path. The visitor controlled the smile. The visitor had no conscious access to the broadcast. The chemistry was always louder than the smile. 6 channels broadcasting involuntarily. 2 channels controlled voluntarily. The animal weighted the 6. The human weighted the 2. The animal was right. The animal has always been right because the animal reads the channel the visitor cannot fake. The physics is complete. The channels are identified. The detection sensitivities are measured. The accuracy is quantified at 93.75% for a single breath sample. What you experienced as animal intuition was molecular detection operating at a scale and speed human senses cannot replicate.